Okay, let's go on to number 24 in the book. So if y'all want to pause the video for just a second, see, find 24 in the book, read through it, just kind of get some thoughts on it, and then let's join in together. Okay, so looking at 24 together, it's one of those hiking problems. And remember, anytime it has to do with bearing, like going northeast, southwest, you always have to give yourself a north-south relationship. And from the north-south, you're either going to go right or left, from there. Okay? So starting from point P, two people are going to walk due east, so straight out to the east, to the right, to point Q. And we're going to go about 1,800 feet. And then from Q, so from there, give yourself a north-south bearing. The two people are going to turn and walk an additional 1,310 feet, so not quite near as far, but in the direction of southwest. So from the bottom, we're going to curve off to the left, and we're going to go to point R. If point R is 1,650 feet from point P, from our starting point, what is the value of the angle? So what angle did we have to curve off when we left from Q to go to R? Alright, so first things first that I want to do is let's draw ourselves a picture. Okay? So I have point P, we'll call that P, and they said we walked due east, 1,820 feet, okay, and then we walked to point Q. From point Q, we walked southwest, not sure how far we walked southwest, we're going to figure that out. We walked about 1,300 feet. And specifically, I think it was 1,310 feet, and that went to point R. Okay, and then they said at the very last piece of information that if point R was 1,650 feet from point P, then we just need to find theta. So theta is right in there. Okay, so it looks like we have three sides of a triangle, and here's a fact, or what we basically want to do is what interior angle of the triangle do we want to know. If we know all three sides, the only other thing we can find is another interior of an angle of the triangle, and what's going to be the best to give us theta. Well, let's look here. If I find this angle right here, we'll just call it alpha, because from point P we walk due east, directly east, this technically right here is 90 degrees. So if I can find theta, then I can find, or if I can find alpha, then I can get theta, but all I have to do is subtract alpha from 90, and that leaves me over with theta. Okay, so let's get alpha. Alpha is, first of all, it's the side opposite, so it's going to be over there. So 1,650 squared is going to be the other two sides, so 1,310 squared plus 1,820 squared minus 2 times 1,310 times 1,820 times the cosine of the angle opposite this side. The angle opposite that side is alpha. Alright, so finish solving. We're going to move those two terms over. We're eventually going to divide off the coefficient on cosine, but 1,650 squared minus 1,310 squared minus 1,820 squared is equal to negative 2 times 1,310 times 1,820 times the cosine of alpha. So like I said, divide off those coefficients on both sides. And then all you have left is cosine alpha equals that. So really, alpha is the cosine inverse. And I'm going to cheat again. That big fraction right there. Okay? We're finding an angle, so we definitely want it in terms of degrees and minutes. So let's plug this in our calculator and convert it to degrees and minutes. And when I do this myself, I get, looks like 61 degrees and 5 minutes. Okay, so again, alpha plus theta, we're going to add up to 90 degrees. So if alpha is 61 degrees in 5 minutes, then theta is going to be 90 minus 61 degrees in 5 minutes. So converting this so we can do the math, 89 degrees in 60 minutes minus 61 degrees in 5 minutes will give us a final answer, right over here, of theta going to be 28 degrees and 55 minutes. Okay, so going back to our problem, that angle right there that we kind of used to represent theta, that kind of makes sense. It's a small, like a 28-degree angle. If what came out was like 100 and something, again, just kind of go back in the context of your problem. That doesn't kind of make sense a little bit, especially if we know that this is supposed to be 90, then how can one part be over greater than 90? So you can kind of use a little bit of your checks and balances systems when dealing with these problems. So again, let's do another one. Let's go with number 30 in the book. So pause, read for a second, and let's come back together. So just to make sure we're looking at the right problem together, let's read it together for just a second. This is what I have for number 30. So a surveyor needs to find the distance between 2 points, P and Q, that are on opposite sides of a large hole. So we've got a pit in the ground and P and Q on the other sides. In order to do this, he placed a stake at a third point, R, and then he uses his surveying equipment to discover that P is 121 feet from R and Q is 130 feet from R, and that angle PRQ has a measure of 47 degrees in 30 minutes. What is the distance between points P and Q? So starting out, I just want to draw ourselves a picture. So we have sides P, we have points P and Q on opposite sides, and then we have an R. And it looks like P is a little bit closer to R, or yeah, closer to R than what Q is. Okay. So let's, P. We'll call this maybe Q right there. And I'm going to make, let's say, I'm trying to draw this somewhat correct. Okay, so P to R, P to Q, and then R to Q. Okay, we know that P to R is 121 feet, and that Q to R is 130 feet, and then they give us an angle. Angle PRQ, so angle PRQ, so this angle right here is 47 degrees and 30 minutes. Okay. And last but not least, now that we got this all in here, they want us to find the distance, I believe. Let me check real quick. We want to find the distance between points P and Q. Okay. So P and Q right there. Makes sense because that's the side opposite the angle that they've given us. Alright, so the side opposite the angle they've given us is x, so we're going to start this equation as x squared is equal to the sum of the other two, so 121 squared plus 130 squared minus 2 times the multiply together times the cosine of the angle opposite the side you're looking to find, which in this case is 47 degrees and 30 minutes. And putting this all in our calculator, because we're just going to get x squared equals, and then we can take the square root of it. Okay? And I do this and get x squared to be, looks like 10,286.93207, yada yada yada. So if we take the square root of all of this, I get x to be 101, let's say point, well actually let's just round it to that, because the other two sides of the triangle are just in 3 digits, so let's just round it to 101, and we'll call it feet. And that seems pretty realistic. My other feet were 121 and 130, so 101 just fits right in there. We can call that problem done. So other than drawing the picture, hopefully y'all getting really comfortable with the law of cosines. Number 34. Let's pause and read, and then let's read together. Alright, making sure we're on the right page with the same problem. You have 2 straight roads that cross each other at an angle of 79 degrees and 15 minutes. Okay, and at a given time, a car on one of the roads is 212 feet from the intersection, and at the same time a truck on the other road is 177 feet from the same intersection. We want to know the smallest possible distance between the car and the truck at a given time. This seems like a typical math problem, doesn't it? Something you can definitely see on like the SATs or something like that. Okay, let's get started by first of all drawing ourselves a picture. Well, we have 2 straight roads. Let's call this one straight road. And what they tell me is that they cross at about a 78 degree angle. So I'm going to try to do this with about a 78 degree angle so I can kind of get somewhat accuracy. Let's see, maybe like that right there. And we'll call this the 78 degree and 15 minutes. Okay. So from there, here's a road, there's a road. We got a car on one of them, and we call this the intersection point. So we got a car on the one and a truck on the other. So let's look at those distances between the cars from the intersection and the truck from the intersection. They say there's a car that's about 212 feet from the intersection, and then they say there's a truck which is a little bit closer, and he is 177. So I'm going to draw him just a little bit closer. And they want to know the shortest possible distance between the two vehicles. So obviously that's that right there. Okay. We label that X, because that's the side we're asked to find. Here's the angle opposite, so it's just like this last problem. X squared is going to equal the sum of the other two sides squared, minus 2 times them multiplied together, times the cosine of the angle opposite the side we want. So 78 degrees in 15 minutes. So plugging this into our calculator, we will get, it looks like 60,990.09 and some change. So by the time we take the square root of this, then what comes out, and let's round it to 3 digits, so it's going to be 247 feet. All right, seems reasonable with 177 and 212 as the other sides. Sounds pretty reasonable.